Is producing tomato juice and tomato paste. The prices of juice and paste are 75 rupees per can of juice and 36 rupees per can of paste. The market share of the company is 48,000 cans of juice and 1,44,000 cans of paste. A can of juice requires 1 kg of tomatoes and a can of paste requires 1/3 kg of tomatoes. The company has contracted to receive 60,000 kg of tomatoes at 7 rupees per kg. Here it is a common data question. It consists two questions. Here the first question is, if x1 and x2 are cans of tomato juice and tomato paste to be produced by the company respectively, then the objective function is. And coming to the second question is, the demand constraint on tomatoes for the LPP is. Here are the some option of constraints. So first consider the given data and form a table. Here from the given data, let us say here take weight of tomatoes on one column per can of juice in kgs, juice or paste in kgs. Let us say for the juice and paste, and another one is available quantity of tomatoes in kgs, and the final column is cost per kg of tomatoes in rupees. So here and write down one more row, that is in one row there are tomatoes and in another row price per can in rupees. So here weight of tomatoes per can of juice is 1 kg and weight of tomatoes per can of paste weight of tomatoes requires per can of paste is 1/3 kg, and here price per can of juice is 75 and price per can of paste is 36. So here and availability is nothing but the company has contracted to receive 60,000 kg tomatoes at 7 rupees per kg. So here 60,000 kg tomatoes at 7 rupees per kg. So this is the given data, and here the LPP is nothing but the profit function. For any firm, the LPP is nothing but the profit function that is given by price function minus cost function. Okay, here price function is nothing but this is the 75 plus 36, and here this is 75 x1 plus 36 x2, and here cost function is x1 plus x2 by 3 at the rate of 7 rupees per kg. So which gives a value of 68 x1 plus it's nearly equal to 101 by 3 x2. So this is the given objective function for the firm or company. So in the options, the correct option is C. C is the right answer for the first question. Coming to the second question, the demand constraint on tomatoes for the LPP is. Here demand constraint is nothing but one is, already we know that the market share of the company is 48,000 cans of juice and 1,44,000 cans of paste. So those two are two constraints. So x1 is less than or equal to 48,000 is one constraint, and x2 is less than or equal to 1,44,000 is another constraint, and x1 greater than or equal to 0 and x2 greater than or equal to 0. And another constraint is, here we have x1 plus x2 by 3 is less than or equal to 60,000, the available quantity of tomatoes. So here x1 plus x2 by 3 less than or equal to 60,000, that is the available quantity. So in the option, the right option is D is the right answer.
You can answer question. It consists two questions such that second question answer depends on the first question. Here the statement for the two questions is consider the following spring mass system as shown in the figure. So the given diagram is the given spring mass system is here one spring is attached with one mass here and another spring is attached with another mass m here. So here first question is the find the effective deflection of the system and the second question is find the natural frequency of the system. So coming to solution, given free body diagram for the given spring mass system is as follow. Here a force due to the spring 2 and here a force due to the mass m, that is mg. Let us say this is mg and another force due to the spring 1, that is f1 here. So here f1 is equal first f2 is equal to mg by using static equilibrium equation, and here f1 is equal f2 plus mg, that is 2 mg. So here the total deflection or equivalent deflection we can say that is f1 by k1 plus f2 by k2, which is equal to 2 mg by k1 plus mg by k2. So this is the given deflection for the given system and is equal to mg into 2 by k1 plus 1 by k2. So in the option, the correct option is B. B is the right answer for the first question. And coming to the second question, find the natural frequency of the system. Natural frequency of the system is nothing but is the root of equivalent stiffness by the equivalent deflection or net deflection, the total deflection for the system. So here equivalent stiffness is equal to, sorry, it is the mass, equivalent stiffness to the mass, or we can write it as the acceleration due to gravity to the equivalent deflection. So already we know that equivalent deflection, which is equal to mg into 2 by k1 plus 1 by k2. So here gg get cancelled and here we have a value of k1 k2 by m into 2k2 plus k1 in the square root. So here this is the answer for the second question, that is in the option, the correct option is C. C is the right answer.